Hello guys, so today we are here to solve our daily lead code challenge for the day. So this problem is about sum of left leaves. So in this we are given the root of a binary tree and we have to return the sum of all left leaves. So we have to return the left leaves. So a leaf is something which has no children. So see here 9 has no children, 15 has no children, 7 has no children, 20 has two children. 3 has two children. The node having value 3 is having two children. The node having value 20 is having two children. Okay. So 9 and 15 are the left leaves, but 7 is not the, left leaf. It is the right leaf. And we are asked to return the sum of the left leaves. So if you do the sum of 15 and 9, it's 24. And that's what the output is. So we have to find out the sum of the left leaves. So only left leaf sum we have to do. We don't have to do the sum of the right leaf. Okay. So since we are asked to, do the sum and that too of a, given a binary tree. So see, a tree is a recursive data structure. So whenever you get a question on tree, try to think of, solving it in terms of, using recursion. And I'm going to do the same here. Okay. So first of all, I'm declaring a variable called sum, and this sum is initialized with the value of 0. Okay. Now, the second thing that we are going to do is check whether the root is null or not. If root is equal to null, okay. So if root is equal to null, since we have initialized sum with 0, we'll be directly returning the value of sum. Okay. Now, after finding that this root is equal to null and we have returned sum. So at line number 19, we have checked if root is equal to null and we have returned the sum. So whatever sum is initialized, that value we have returned, or whatever sum value is at that moment, we are returning that. When we come to line number 20, it means that root is not equal to null. If root is not equal to null, then it means that it can have left or right children. So if root dot left, we can check if root dot left is equal to null. So in this case, what we will do, in this case, what we will do that, return sum of left leaves, and then we can pass here root dot right like this. Okay. If root dot left is equal to null, then we are returning sum of left leaves and we are passing the right child of the root because the left child is null. Now at line number 20, we have checked if root is of the left child of the root is null or not. If it is null, then we are passing the to the sum of left leaves, the right child of root. But when we come to line number 21, it means that the left child of root is not null. If that is not null, then there is a possibility that that left child could be a leaf node. If that is a leaf node, then how can we check that? So we can check this by using root.left.left is equal to null and root.right.root.left. Oh, sorry, we only have to do the sum of the left child, and left child's right node is also equal to null. Then in that case, what we will do, that sum is equal to root dot left dot val like this. After doing this, what we will do, that we will so we have checked if left child is a leaf node or not. In case it is not a leaf node, then what we'll do? In case it is not leaf node, then we will just take this, sum of left leaves, and then just, call the sum of left leaves dot root dot left. Okay. And so if left leaf, if left node is not a leaf node, then we are passing to the sum of left leaves, the left child, and a tree can also have a right child. So in that case, we have to call this, we have to call this, and after passing this, we are taking the sum of this. So sum like this, and then at the end, we'll be returning the sum like this. Perfect. Perfect. So this is a efficient solution. Let me know if you have any doubt. So first of all, what we have done, we have initialized a sum variable to be 0. And then at line number, after initializing that sum variable, we are checking whether the input root value is equal to null. If it is equal to null, then whatever is the initial value of sum or whatever is the value of sum at that point, we are returning that. Okay. And then since we have confirmed that root is not equal to null, because whatever, if it is null, we have returned the sum. If it is not equal to null, then we are taking root dot left is equal to null. So if root dot left is equal to null, so we are checking like, whether the left child of root is equal to null or not. So if it is equal to null, then we are, calling sum of left leaves on the root's right child. Okay. So at line number 20, we have checked if root of left is equal to null. So when we come to line number 21, we have already, ascertained that left child is not null. So if it is not null, then it could be a leaf node, or it could not be a leaf node. If it is a leaf node, then we are taking in the sum, the value of that left child. If it is not leaf node, then we are taking sum plus is equal to sum of the left leaves dot root dot left. So we are passing root dot left to the sum of the left leaves, and whatever is the sum we are returning, we are accumulating that in the sum variable. And then this, since we have already, only thought about the left child, we have also to think about the right child. So on line number 23, we are doing sum of left leaves dot root dot right, and then again we are accumulating the returned value into the sum value. Okay, just like, see in this example, in this case, we are initializing the sum is equal to 0. If root is equal to null, then whatever initial value is there, we are returning there. But if root is not equal to null, then it could be having a left child and right child. If the left child is null, then we are, if this branch is not there, then we only think about this branch, and then we think, return sum of left leaves of root dot right. Okay, so we are not, considering the left subtree because the left child is null. So only we are considering about the right subtree, right child subtree. And for that, we are just causing sum of left leaves dot root dot right, because this 15 is also there, and we have to take the sum of this 15. If this branch is not there, only this subtree is there, then in this subtree, the 15 left child is also there. So we have to take into account that 15 value as well. After doing this, what we are, sure of that the left is equal to null condition has been checked. So either the left child is there, or if it is there, then it could be a leaf node. Okay. So if it is a leaf node, then that condition we are checking in line number 21. Otherwise, what we are doing that, we are just calling sum of left leaves dot root dot left. So suppose there is further subtree down there, then this line will be taking care of that 22 line number 22 will be taking care of that, that condition that, if there are further subtrees down the node having value 9. Okay. Otherwise, we have to consider the right child, and to consider the right child, we have to do this sum of left leaves dot root dot right, and whatever is the sum is coming, that final value of sum is we have to return. And that's how this problem is solving this, that's how this code is solving this problem. So I hope this is clear to all of you. If you have any doubt, please post it in the comments, and I'll definitely try to answer those doubts. With this, I'm thankful to one and all. Happy coding, best wishes.